Somewhere out in the universe, a black hole 10 million times the mass of our sun is currently moving through space at nearly 1,000,000 miles an hour, completely untethered from any galaxy, dragging a trail of glowing gas and stars behind it for 200,000 light years. Nobody put it there on purpose. Nobody predicted exactly where to look for it. And until the James Webb Space Telescope happened to catch it mid-flight, nobody had ever seen direct evidence of a supermassive black hole simply wandering loose through the cosmos like this. This is the story of what astronomers now call a runaway black hole, an object so bizarre that researchers are still working out exactly how something this massive ended up completely alone, cut loose from the galaxy that presumably built it in the first place. Stick around, because the evidence behind this discovery is honestly stranger than anything you'd expect from something invisible, and if you want to catch every new discovery to come out of Webb's ongoing hunt for these things, go ahead and hit follow before we get into it. To understand why finding something like this is such a big deal, you first need to understand a basic assumption astronomers have relied on for decades, that supermassive black holes live at the centers of galaxies. Nearly every large galaxy in the observable universe, including our own Milky Way, is believed to host one of these enormous objects sitting quietly at its core, anchoring the surrounding stars and gas with its immense gravity. That relationship is so consistent that finding a galaxy without one would be considered genuinely strange. So the idea of a black hole, existing completely apart from any galaxy at all, drifting through open space with nothing surrounding it, runs directly against one of the field's most reliable patterns. The problem with actually finding one of these rogue black holes is that black holes, by definition, don't emit light. You can't simply point a telescope at empty space and expect to see one sitting there. The only way astronomers can typically detect a black hole is indirectly, either by watching how it influences nearby matter, or by catching the rare, brief moment when it's actively consuming something, producing a flare of radiation as material falls in and heats up before disappearing past the point of no return. Finding an isolated black hole, one with no galaxy, no companion, and nothing obvious nearby to interact with, requires an almost accidental stroke of luck, catching it at exactly the right moment, doing exactly the right thing for its presence to become visible at all. That's essentially what happened when a research team led by Yale astronomer Pieter van Dokkum went digging through archival images captured by the James Webb Space Telescope. While examining a distant galaxy, the team noticed something distinctly unusual. A long, strikingly straight, glowing trail of gas and young stars stretching out from the galaxy across an almost unimaginable distance, roughly 200,000 light years long, nearly twice the width of our own Milky Way. Straight lines like that don't typically show up in nature at this cosmic scale. Galaxies are messy, swirling, gravitationally chaotic environments. A perfectly straight streak of glowing material cutting across. One of them looked to the research team distinctly artificial in its geometry, the kind of feature you'd expect from something moving in a single, sustained, unwavering direction rather than something shaped by the usual turbulence of galactic dynamics. Van Dokkum and his colleagues proposed a genuinely wild explanation for what they were looking at, a bow shock. That's the same basic phenomenon you see in the wake of a boat cutting through water. A compressed, disturbed region of material piling up directly in front of an object, moving fast enough to push everything out of its path. If this streak really was a bow shock, it would mean something. Extraordinarily massive was plowing directly through the gas of its host galaxy at tremendous speed, compressing that gas into the glowing trail Webb had captured, and leaving a wake of newly triggered star formation stretched out behind it like the churned water behind a speeding vessel. Based on the physics required to produce a bow shock of that scale, the team calculated that whatever was doing the pushing had to be a black hole roughly 10 million times the mass of the Sun, traveling at almost 1,000 kilometers per second, an extraordinary speed for an object of that size. This wasn't an isolated case either. Around the same time, a separate research team studying a different galaxy called NGC 3627 found a remarkably similar feature, another long, straight contrail, this one roughly 25,000 light years in length, consistent with a somewhat smaller black hole around 2 million times the mass of the Sun, moving at approximately 300 kilometers per second. Two separate independent sightings of the exact same strange phenomenon, straight contrails apparently carved out by massive black holes plowing through their host galaxies, gave researchers real confidence that they weren't just looking at some kind of coincidental imaging artifact or a misidentified, more mundane astronomical feature. So how does a black hole end up moving through a galaxy at these kinds of speeds in the first place? The leading explanation involves one of the most violent events that can happen in the life of a galaxy, a merger between two black holes. When two galaxies collide, their central supermassive black holes eventually spiral toward each other and merge into a single larger black hole. But that merger process isn't always perfectly smooth or symmetrical. If the two merging black holes have unequal masses, or if their spins aren't aligned in exactly the right way, the resulting gravitational wave emission released during the final collision can come out lopsided, radiating more strongly in one direction than another. Because gravitational waves carry momentum, that asymmetry produces a recoil, essentially a kick, sending the newly merged black hole rocketing off in the opposite direction at extraordinary speed, sometimes fast enough to escape its host galaxy's gravity entirely. If that explanation holds up, these runaway black holes aren't simply strange cosmic oddities. They're direct physical evidence of a galaxy merger's violent aftermath, still playing out visibly in real time, long after the actual collision that produced the kick occurred. Van Dokkum pointed out something genuinely intriguing about what these discoveries reveal, noting that in both cases, researchers were left looking at a massive black hole sitting essentially alone in empty space, describing the situation as scientifically fascinating, precisely because it's the kind of scenario that shouldn't be observable under normal circumstances. Both research teams have said they plan to actively search for more of these wandering black holes going forward, hoping that a larger sample could eventually help settle exactly how common this kind of violent gravitational kick actually is across the broader population of galaxies. Runaway black holes aren't the only kind of isolated black hole Webb has managed to track down recently. A separate discovery, made by a team using a specialized machine learning algorithm trained to detect a specific kind of stellar destruction event, turned up something scientists have started calling a truly wandering black hole, found sitting at the edge of a large galaxy with seemingly no visible connection to anything around it at all. This one was found in a completely different way, not through a static, visible trail, but by catching the object in the act of tearing apart and consuming a passing star, an event astronomers call a tidal disruption event. Archival images of that same location, taken before the flare occurred, showed absolutely nothing there. No visible galaxy, no earlier hint of activity, essentially confirming that a supermassive black hole had been sitting completely hidden in that patch of space the entire time, only becoming detectable for the brief window while it was actively feeding. Researcher Yuhan Yao, involved in identifying that particular black hole, remarked that you simply wouldn't have suspected anything was hiding there at all before the flare revealed it. And once flagged, the team was able to bring in Webb specifically to study the event in infrared light, an especially valuable opportunity, since a black hole sitting in genuinely empty space without a bright host galaxy surrounding it allows scientists to observe its feeding process with none of the usual interference from surrounding starlight, giving them an unusually clean look at exactly what happens when a black hole consumes a star. Even stranger discoveries have come out of Webb's broader hunt for isolated black holes in the distant early universe. Researchers led by Cambridge astrophysicist Roberto Maiolino identified what they've described as a completely off-the-scale object, an enormous black hole, roughly 50 million times the mass of the Sun, sitting almost entirely alone in the early universe with only a small handful of stars orbiting anywhere near it. That discovery genuinely confounds existing theories of how galaxies and black holes are supposed to form together during the universe's earliest chapters, since current models generally assume black holes and galaxies grow up together, feeding off the same surrounding material. As they develop side by side, finding a black hole this massive with essentially no galaxy around it raises real questions about whether some of the earliest, most massive black holes in cosmic history might have formed before their host galaxies ever fully came together at all. Taken together, these discoveries are quietly reshaping how astronomers think about where supermassive black holes actually exist and how they end up there. The old assumption that these enormous objects are always safely anchored at the center of a galaxy, surrounded by stars and gas, locked into a stable, orbiting relationship, turns out to be an incomplete picture. Some of these black holes get violently ejected from the very galaxies that made them, still visibly plowing scars through the gas behind them. Others may form essentially naked, isolated from any surrounding galaxy almost from the very beginning. And some sit quietly, hidden in the darkness between galaxies entirely, completely invisible until the rare, brief moment they happen to consume something and give themselves away. If a story like this, an invisible object 10 million times more massive than our Sun, quietly carving a 200,000 light-year scar through space as it flees the wreckage of a galactic collision, is the kind of thing that genuinely fascinates you, go ahead and subscribe. Drop a comment, letting me know how many more of these runaway black holes you think are out there waiting to be found, and stick around, because both research teams chasing this mystery are actively looking for more of them right now.